Okay, so the law of cosines, you can check out the proof online later. We're on page 841. The law of cosines looks like three different equations, but if you'll notice there's this very definite pattern to it, and it's all really just one equation from three different points of view. The biggest thing you got to do is figure out which angle you're talking about, because each of these only use one angle. Okay? So what I'm going to do is I'm going to look at my picture. Remember, it works in two situations. This particular situation is side, angle, side. It's the nicest, prettiest situation to use law of cosines. Okay? You notice I was given this side, and the angle in between. Okay? And that's what it's going to look like. So side, angle, side is where we're looking at. All right, what I want to do is I just want to identify this particular triangle is not labeled. So I'm going to label it with A's and B's and C's. And I think just for simplicity's sake, I'm just going to use cosine of A. I'm just going to make this my A. So if I call that an A, then what is this piece over here called? Little a. And now what about B and C? Okay, it really doesn't matter. You're absolutely right. In order for me to match the picture in the notes, I'm going to put B on the bottom, but it absolutely doesn't matter. So that's big B up here, little b down here, which makes angle C over here and little c there. Now from here on out, guys, this is going to be a very straightforward, follow a formula, plug and chug. Okay? So I got a brand new situation. Oh, actually, let me restate that. My question said, find the perimeter. You know the perimeter is going to be 10 plus 12 plus something, right? So it's the something we're looking for. What are we looking for? Little a? All right, we're looking for little a. So I'm going to do a squared equals b squared plus c squared minus 2bc cosine a. Now that's a new formula. We're going to have to memorize this one. We got to know it. But we're pretty good at using formulas, so all we got to do is plug in. Do we know little a? No. What about little b?
Yeah.
Okay, that's going to be 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 25 degrees. Good. Now, are we in degrees? All right, make sure you're in degrees in your calculator. Okay, it is very, very tempting at this point for you to plug this entire thing right in your calculator, and I see some of you doing that, but I would say stop. I would say make sure that you follow your order of operations and just go slow and steady. It will help you tremendously on the side problems if you can understand the side angle side problems slowly. Okay? So, just my order of operations. Of course, I got those exponents. 12 squared is 144. Plus 10 squared, which is 100. Now, I already took care of my squares, so I think I'm going to do two steps in one. I'm going to go ahead and multiply 2 and 12 and 10. So that gives me minus 240 cosine 25. What can you do next? Okay. I actually have two different things I could do at the same time because one doesn't affect the other. But order of operations, I've got to multiply, right? 240 times cosine 25. So that's going to be something minus, what's 240 times cosine 25? Yes. Okay, so you're right. It's going to be 217.5. And at the same time, I guess I can add these up now. 144 and 100 is going to be 244. So a squared is going to equal 244 subtract 217.5. Well, I can definitely do that now. Okay. So 26.5, and then of course to get a, you're going to square root that 26.5, and that's approximately, all right, approximately 5.1. So, of course, to answer the actual problem, I would take that 5.1 and I would plug it in up here. And my perimeter would be 27.1. Okay, I'm not really worried about the perimeter as much as I am about using the law of cosines. So the first thing I'm going to do is I'm going to go ahead and label my angles. And again, we just talked about where these angles are as far as 15 degrees west of south would be right here. And then right here would be my 25 degrees east of south. Okay, so I went ahead and labeled those. Now, immediately some of you recognize, what's 15 and 25 together? All right, so together the whole angle is 40 degrees, right? And I don't know which one of those I'm going to need, you know, but I'm just going to be prepared to have both of them. All right, so my given information, once again, they've given me a side, an angle, and another side. So this is a side angle side. So this is definitely a law of cosines problem. How do you want to label your triangles? Let's just leave it with an A. That's the easiest. Okay. Now, if you want to, we can make this the letter C if you want to, and then this would be little c. We can make this angle B, and that would be little b. It works perfectly fine. You just want to go ahead and label them. All right. So I'm going to get rid of my side angle side here. Call this little a. Call this big A, which makes these my little b and my little c, right? All right, so, hey, it's just a brand new formula. Copy it down. Make sure you know how to use it. A squared equals, anybody tell it to me yet? B squared.
Minus 2bc cosine.
All right, there's a couple of you that are pretty close on that. You just want to make sure you study this, okay? Take the time, read over it. At breakfast, hand it to your mom or dad. Have them quiz you, because you definitely want to know these, okay? All right, fill in the blanks. A is what I don't know, equals b squared. We decided that was 5 plus 7 squared minus 2, 5, 7 cosine. How big is that angle? 40, because you had to put those together. All right, and then it's just follow order of operations. Now again, I know it's tempting, but I promise you, you're better off if you don't put it in your calculator. So that's 25 plus 49. Now I do have negative 2 times 5 times 7. That's going to be minus 70 cosine 40. Now what can you do? Yeah, I can do the 70 cosine 40.
53.6.
And I can also do the 25 and the 49. They are two different operations, you know. I was just trying to combine some stuff together. What is that? 70, 74.
Oh, yeah.
And then you subtract them. And that's 20.4. And then, of course, your final step is just going to be the square root of that. And we found out it's about 4.5. So clearly, this is the angle I need to know. I can call it any angle I want to. Do you want to call it A, B, or C? That's fine. A sure makes the most sense, but it really doesn't matter. Okay? If that's A, then of course, the 2 is little a. Which one's B and C? All right. Really doesn't matter, but you can call the top one B and the little one C, and call these like that if you choose. All right. So set up your law of sines. Oh, by the way, we should have cosines. Excuse me. Thank you. Remember, this situation here is a side situation. Okay. The only given information they have are the three sides. The three sides will always be the law of cosines. Okay, this is the situation from the beginning of class. All right, so now I'm sitting here ready to go. So I'm going to set it up. Let's see. If I'm using angle A, then I should be using little a first. So I've got a squared.
Could you go ahead and put like the 2 right there?
Yeah.
I could. I'm just going to always write down my formula since this is brand new. I don't want to forget something. All right, but yes, you are going to have to plug these in. So that's 2 squared equals 5 squared plus 6 squared minus 2, 5, 6. Cosine of A. That's right. A is what I don't know. Now, here's where your order of operations are very important. All right. You can take care of your squares first. And you can also take care of that multiplication. So let's take care of those small things first. 2 squared is 4. 5 squared is 25. 36. And go ahead and give me 2 times 5 times 6. That's going to be minus 60 cosine of A. Now, most of you, I think, see like terms immediately. So I'll go ahead and put those together. Yes, I know I'm probably showing more work than you might. But that's going to give me 61 minus 60 cosine A. Now, deep in my heart, I have a feeling I know what you're going to do. You're going to do 61 minus 60, right? But you cannot. Because I would remind you that 61 minus 60x are not like terms, are they? And isn't this really the same thing? It is. So, with that being said, write yourself a note. Not like terms. Because this right here is probably one of the most common mistakes that happens with the law of cosines. So now that we're aware of that, we can avoid it. How am I going to get the 60 cosine A by itself?
Minus 61.
Minus the 61. Very good. Okay, and that's going to leave me with negative 57 equals, what does it equal? Negative 60 cosine A. Good. Do you notice that this negative, don't lose that negative. Okay. Now, how do you get cosine A by itself? Okay, not yet. I got to divide by negative 60. Right? And I'm sorry, I'm going to have to slide over here to finish my work. But that leaves me with positive, because they both end up being 0.9500 equals cosine A.
Why wouldn't you take the cosine with the 60? You take the x?
Because I can only do the inverse cosine when it's just a plain old cosine. I have to get rid of the coefficient in front of it. Okay, so that's why I get divided by the negative 60. But that really just kind of answered the next step, didn't it? How do you get the A by itself? You're going to do the inverse cosine of both sides. And those two go away. So that should give me my angle. Angle is approximately 18 degrees. Right? So go back and answer the question. Will I make it? Alright. So we chose this angle up top as angle A, which makes this little a. It doesn't really matter which one is B and C, but we'll call this one B and this one C. Alright. In order for me to find the area, you guys have already told me that I could use my new area formula, 1/2 BC sine A. The problem is I'm missing A, right? I almost have everything, but I'm missing the letter A. So what I need to do is I need to go find it by using the law of cosines. So I write down my formula, and then I plug in what I know. All right. Once you plug in what you know, you're just going to start working through your order of operations slowly. That's 400 equals 100 plus 225 see, this is all going to be minus 300, right? Minus 300 cosine A. Remember, you can put these two together. So that's going to give me 400 equals 325 minus 300 cosine A. And then, what do you do with the 325 minus 300?
No.
Oh, exactly. Thank you. You cannot do this. These are not like terms. So instead, I subtract the 325. That gives me 75 equals negative 300 cosine A. And when you divide, you get that the cosine of A equals negative 0.2500. And then the inverse cosine Alright. And then the inverse cosine down at the bottom ends up being, what is it? 104? Okay. Now remember, this was pretty complicated, but I did all of that work just to find angle A so that I could plug it into my formula. So if that's 104 there, then my answer to the area is 1/2 times 10 times 15 times sine of 104. So the final answer is 72.8 square feet. Guys, I want to do a quick little summary of when to use what type of work, okay? When do I use my SOHCAHTOA right triangles? Only if I have a right triangle, okay? Now we remember sometimes we have to make one. For example, sometimes I could make one right here, okay? I could always make one. But a lot of times that makes things very difficult. All right. When do I use the law of sines? I use the law of sines whenever I'm given one of these three situations. Two angles in one side, and it really doesn't matter if the side is between the angles or not between them. And then there's another situation, two sides and the angle outside of it. But the law of cosines is really the one that sticks out to us the most. We need to use the law of cosines with side, 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 and side, angle, side. So let's go through these three triangles, purple, green, and yellow, and let's decide which one should I use as I do this work. For the purple triangle, what information was given? Okay, that's going to be side, side, side. So this is definitely cosines. For the green triangle, they've given me an angle and a side here and a side here. I know, don't look. Anyways, what situation is this? Side, side, angle. Side, side, angle is definitely the law of sines. And then finally on the yellow triangle, they've given me an angle, and where's this side? Okay, it's after the two angles. It's not in between them, is it? But it's still law of sines.